Good morning, everyone. We are going to start our presentation for the case for public use data sets. Today we'll start out, we're going to start with a question. Have you ever felt like this? So you've developed an explanation or a hypothesis, but you just need to find the data to support it. In this case, it's the data for supporting the conclusion that eating chocolate will make you look younger and thinner, and we just need to find
I just said it out loud.
the data for it. Believe it or not, you can find data sets on chocolate. I found out that Americans eat 2.8 billion pounds of chocolate annually, but nothing, I couldn't find anything to support this conclusion. However, I suppose if I keep looking, I might be able to find it, but I'm sure I'll keep eating it though. Today, we'd like to welcome you to the presentation on public use data sets. Thank you for joining us. We appreciate you taking the time this morning out of your day for this presentation. My name is Kent Ripplinger. I'm the database navigator for the DaCCoTA, and I'm joined, Dr. Mark Williamson is also joining the presentation. He's a statistician and has a lot of expertise in this area. So as we continue, we'd like to accomplish a few things this morning. First, we'd like to define what public use data sets are, how they can be beneficial in your research, discuss and maybe list some tools available for you to search for public use data sets that might help you answer your research question. And we'd also like to see some specific examples of how public use data sets have been used to answer research questions. With that, what are PUDs? Well, PUDs are public use data sets that are considered to be de-identified, which basically means the name, social security numbers, things like that, that can identify the individual have been removed. They can be freely downloaded for the most part. I mean, some require possibly a short application to request the data, but there is no formal written agreement that's required between you and the provider of the data. They're usually maintained by government agencies, run with government funding. A good example of this is data.gov. It's a website managed and maintained by the United States government that can be used to find and download data sets from a variety of topics, from climate to the health of older adults. The data is fixed. Obviously, if other people have done the research and collected the data, the samples and variables are all fixed. Basically, the data is what it is. And many are free, which is attractive, but for the most part, free, possibly a small fee to offset some of the costs. I did want to point out that there are some differences between public use data sets that we were talking about versus restricted use or limited use data sets. They're a little bit different. Limited use data sets typically require a contract, like a data use agreement, to access variables or identifiers in the data set. And because of this extra layer, typically will require an IRB approval. That's a limited use data set. A good example of a limited use data set is the National COVID Cohort Collaborative, otherwise known as the N3C. I will be offering a presentation on the N3C on October 26th. So be on the lookout for that registration link. Hopefully you'll have some interest in that. And it's a vast amount of data created for COVID research. So the question is why? Why use public use data sets to analyze data for your research question? I can tell you from my experience outside of the research world, my previous 31 years were
came out of that meeting complaining about we're okay.
I would
this
not,
was
if
the
somebody would ask me what I thought
reviewers. It goes to the
was,
board. That's right.
was considered research, or what I would think of when I think of research, it certainly wasn't the idea of digging through vast amounts of data. It was more along the lines of a scientist in a lab doing research and making some new amazing discovery. And this really came to light for me when I was working with an investigator earlier this year who was familiar with public use data sets, but had never really used them. He had always done his research in a lab working with mice, trying to come up with, using his research to answer his question through traditional, I guess, or what most people would think as a scientist in a lab. So using established data probably wasn't first and foremost on his mind. So I hopefully after this presentation, we can at least show the benefits and how they can be helpful in your research. Which brings me to some benefits that we see public use data sets providing you. One of them is it's vast amounts of data that's readily accessible. Some of these data sets contain thousands to hundreds of thousands to millions of records that you can get excited about digging into to help answer your research question. The cost is also attractive. They're usually low or no cost. So if you're a relatively new researcher or you don't have the funding, this is a good way to start your research career. The time saved, you don't collect the data. The data is already collected, obviously. The other advantage to public use data sets is the data is more geographically diverse, because a lot of these data sets are collecting data from many parts of the country, possibly many parts of the world. So you have access to not only vast amounts of data, but vast amounts of data from many geographic locations. You may have annual collection of the data, which could allow for cross-sectional or historical or trend analysis. Obviously, it's lower risk to subjects since you're not subjecting anyone to experiments. All of the experimentation is already done. The initial data management is done by the organization, so you don't have to worry about the time to enter data, to prep the data, to organize the data. It's already done. And the nice thing about this is because the data is publicly available, there's typically no IRB review, or if there is one, it's abbreviated. So the time it takes to access the data, the time it takes to research and analyze the data is saved through public use data sets. Now, how would you find public use data sets? Well, you could do things as simple as putting in a Google search if you wanted to see what's out there. But there are some better ways, I think, of looking for data sets. One, Google has a data set search, pretty easy to use. You just type in a keyword, it'll list a number of data sets that might be beneficial to you. Kaggle also has a search engine that typically you type in a keyword or a topic, a search area, subject area, and it will list applicable data sets. Data.gov, we've already mentioned that, but it's ran by the United States government. It's an open data source. This site has over 125,000 data sets. And the last one I'm going to mention is the CDC has a number of data sets available to help you in answering your research questions. So we were talking about the benefits of public use data sets. We also hope that as you explore data sets, it might help you develop a line of research questions or discover questions that are not answered by reviewing the data. We also think that as you get into initial research and looking at the data to answer your question, it might lead to a larger research project. And finally, it can be used to identify gaps. You may notice there's data that's missing, and you might determine that there's some next steps that can be done to advance this area of research. I don't have a lot of experience in this area, but fortunately, Dr. Mark Williamson does. So he's going to add a little bit more to this part of the presentation.
Yeah, sure. So these questions aren't mutually exclusive. They often build off of each other. I think that the big thing with public use data sets is that while they might not be able to answer really specific like causal questions, they help get the ball rolling. One thing, for example, like this, discover questions or start developing a lot of research questions. Something that's very crucial to the scientific process is hypothesis generation. You know, coming up with useful, important questions to answer. And while many like lab techniques or scientific literacy, a lot of those things are taught, hypothesis generation isn't always taught very well or even brought up, and kind of left to researchers to kind of figure out themselves. So using public use data sets is a great way to start thinking about how to generate questions depending on the data available and try to answer them. In a little bit here, I'll be going through some specific examples of data sets, and we'll see examples of, say, using public use data sets as a foundation for a larger research project that actually goes into the lab. So I think with that, I'll switch back over to Kent.
Thanks, Mark. Just a couple things that we'd like you to consider when you're looking at using public use data sets. One, what is the quality of the data? So really the questions are, how well can you understand the data collection methods? What is the sample size? How old are the reports? Things like that. What was the original purpose of collecting the data? What are the credentials of the author? And one of the things too, you have the ability in some of these data sets to see if anybody has published from the data set. As in the information, they'll explain how you would cite that data set in your research. You could search for those who may have used that data set in their research. You also would like to consider the fact, is there a data dictionary or a manual that can help you see what exactly is in the data set? And of course, what data is available is also something to consider. What are the variables? How are they defined? Some of that might determine what type of analysis you can use with the data. And we also should consider, if there was data missing, how did the public use data set team manage that missing data? So just some things to consider as you dig through some of the data sets that might be valuable to you. I think now we're going to move to Dr. Williamson is going to give some really good specific examples of how he has used public use data sets in his research. So I'm going to stop my screen share and Dr. Williamson is going to take over.
Okay, so here is the first example I have here. It's a paper called Brain Cancer Incidence Rates in the Presence of Nuclear Reactors in US States, a Hypothesis Generating Study. So brain cancer is a complex of multiple different types of tumors and really have an unknown etiology, or that is cause. Now, the only real established risk factor for brain cancer is ionizing radiation. And ionizing radiation, think X-ray machines, not microwaves. So there's a lot in brain cancer. There's a lot of potential to need to generate hypotheses about possible causes. So using state level brain cancer incidence data from the state cancer profiles, Dr. Schwartz, Dr. Klug, and I examined rates of brain cancer in the presence of nuclear reactors. We actually found a small but significant correlation between research reactors and brain cancer rates. Here's an example of the map here. The bluer it is, the higher the brain cancer rates. And then states with one reactor have a yellow, and then states with more than 2 or more have red. You can see it generally tracks. You see these bluer states and like Texas, some of this Northeast states have more research reactors and also higher rates, where thankfully, if you're in North or South Dakota, it looks like we have pretty low brain cancer incidence rates comparatively, though it's not, of course, a perfect tracking. You see New Mexico here has more than two or more reactors, but they have low rates as well. So research nuclear reactors are actually different from power reactors. So power reactors are the ones that generate electricity for homes and businesses. Think of those giant smoking stacks. Research reactors are not those. They're typically much smaller and actually found a lot of times in either national laboratories or universities. And so while we found this link, or this correlation more accurately, it's unclear what the actual mechanism would be. So that's why we stressed, even in our title, that this is just a hypothesis generation study. Broad level data like this is only the first step in establishing a definitive link. A next step might be to, say, follow cohorts of researchers at universities with research reactors and see if they have higher rates of brain cancer than the general public. Things like this have already been done for, say, conventional nuclear power plant workers. Here's another example of public use data sets centered around Parkinson's disease, another neurological disease, or another disease that deals with the brain and doesn't have entirely known causes. So heavy metal exposure is a possible risk factor for Parkinson's, and metals can be leached into water systems by acid rain. So our working hypothesis with these two studies was that more acid rain leads to higher concentrations of heavy metals in drinking water, then blood, then the brain, and then can lead to increased risk of Parkinson's disease. So to test this, we took prevalence data for Parkinson's from a previously published study. So this is another example of, so we use it from Mantry et al. This is another example of a publicly used data set, so from another study. You might not think about that right away, but that's certainly available to use. Of course, citing it and referencing where you got it from, as you would with any of these data sets. So we compared it to a metric we devised, the acid precipitation index, which combines precipitation rates and pH of the precipitation rates to sort of get a metric for the strength of acidification to water systems. We also included confounding factors from other public data sets, including well water uses and sulfuric acid release, which might relate to Parkinson's. And what we found was a significant effect. States with higher acid precipitation index tended to have higher Parkinson's disease. Then we followed up this study with a similar study that looked at lead service lines. So lead service lines from the National Survey of Lead Service Line Occurrence. These are the underground pipes that connect homes to municipal water sources. And lead is a heavy metal. So again, while using some other confounding factors, we did find a significant effect. States that had higher number of log lead service lines tended to have higher Parkinson's disease rates. Now, here's where the research story really takes off. Based on these results, Dr. Foster, a Unity professor, applied for and received a DaCCoTA grant and to follow up on this potential link. His project, Environmental Lead Exposure and Dopaminergic Dysfunction, aims to examine the acute effects of lead in cell culture medium and chronic effects of lead in drinking water of adult rats on the neurological dopaminergic system. So this is a great example of public use data sets informing a larger research project that actually takes these high level correlations and tries to experimentally confirm them in something, say, mice or cell culture. Now, on a different tact, a couple years ago looked at the success rates of cancer control objectives across US states. So for this one, I compared state cancer control plan documents. So pretty much every state has a document that says how they're going to try to control cancer in their state, and they'll have various objectives to try to achieve that. So I looked to see if objectives from earlier plans were achieved or not by comparing an earlier plan to a more recent plan. So these objectives might be like increasing mammogram screening rates or reducing smoking, etc. For example, one objective in North Dakota State Cancer Control Plan was increasing breastfeeding areas in work sites because it might be linked to lower breast cancer rates, increased breastfeeding. So the original objective in, I think, the 2012 to 2017 plan was increasing target sites from 0 to 10. And then this is the more recent one in 2022. We see that their baseline is already 136, which means they clearly succeeded in their early objective of getting up to at least 10. While this was a successful objective, it turns out it was only one of the very few successfully met objectives for North Dakota and, in fact, the US overall. Here's all the states. Many states, in fact, I couldn't even get clear success rates compared between the two. So overall, success rates of cancer control objectives in the US were low, which suggests state cancer control plans might want to opt for fewer, more targeted objectives rather than a broad swathe of general objectives. So this is an example of not using a strictly like a table of data or another data set like that, but taking information that's generated that has data in it and extracting it out and compiling it yourself. So that's another way of looking at using public data. Then here's a final example, which carries within it a word of warning about public use data sets. So this study was on radon, criterion validity of radon test values. So radon is the second leading cause of lung cancer and may contribute to other health issues. So there's public data available from commercial companies such as the company AirCheck, which manufactures radon test kits. So this data is available for people, and indeed AirCheck data has been used in published studies on radon. But it's unclear how accurate that data is. So Dr. Schwartz and Dr. Klug took these commercial values and compared them to the Environmental Protection Agency. They've done several large surveys. So this is sort of the gold standard of radon detection. These are both at the county level. And they compared the two across 5 states in the counties. One of the states was North Dakota. And while they found there was, fairly strong correlation between the two, they found that the commercial AirCheck rates significantly overestimated radon levels at low values. What's more, it's kind of hard to see here. I'll see if I can kind of draw a little bit. For North Dakota, they were the green squares. Let's see if I can. There's actually a negative correlation between the values. So these lines are plotting the overall trend, but if you just looked at North Dakota, it probably looks something like this. So what that means is the relationship with AirCheck and EP values were reversed. High values matched to low values. High values of AirCheck matched to low values of EPA. So this public use data wasn't particularly accurate, especially on things like North Dakota. And that's important to note, that not all data is as accurate as you might like it. Okay, then, while I showed the use of public use data sets on published studies, I want to show you another benefit of using public use data sets. Being able to quickly generate hypotheses, test these hypotheses, and then move on when nothing is found. So without sinking a whole lot of time, funding, or effort, here are some relationships that I found to be insignificant while researching different topics. So I looked at melanoma rates and radon levels, stroke rates and radon levels, brain cancer and arsenic, brain cancer and the acid precipitation index, multiple assistance atrophy rates in lead surface lines. So that's another neurological disease, motor neuron disease in lead surface lines, as well as Parkinson's and coal plant numbers and renal cancer and coal plant numbers. So not to say that there is absolutely no connection between the two here, is just with the data I looked at, initially there was no relationship, so there wasn't an incentive to try to move on and examine these in more details because it didn't seem like there is, if there is a real effect, it's not very strong. All right, last to finish out, I want to give you a glimpse of some of the research questions I'm currently working on using a public use data set, courtesy of the National Environmental Public Health Tracking Network. I'm going to stop sharing here and switch over to, let's see here. Here is the National Environmental Public Health Tracking Network. It's hosted by the CDC. You're able to look at both geographic data. You can also download these as tables of various health and environmental data. So for example, I was talking about radon. You can look at radon. You can look at various different indices. I'm just to say, let's say from labs, look at mean pre-mitigation radon levels. Let's do by county, or sorry, national by county. And we'll do the more recent time frame. And just with a couple clicks, it can generate a map with all the data here. And then the light yellow means low rates, 0 to about 2. The orange is 2 to 4, and then red is greater or equal to 4, and that's 4 picocuries or 4 picocuries per liter is the cutoff for where you should probably remediate your home if radon's that level. And you can see here why it might be important to talk about radon in North Dakota is almost all the counties are red. Now, another feature of this is you can actually compare values of different variables side by side. So say if I wanted to look at another variable, say I'm just going to do air quality, maybe air toxics, look at annual concentration estimates. We'll do the same sort of thing, national by county, more recent years, and we'll just do benzene. And you can see here, you can look side by side at this. So I'll switch back over. Let's see. Okay. So with that, just a little warning. You just saw there's all sorts of data from the National Environmental Public Health Network just at your fingertips. In a couple of seconds, I was able to get 2 maps up. If you just take a bunch of variables and compare them, you could certainly do that with this data set or another data set. And you could compare a bunch of different variables until you found some significant correlations. Now, that's actually a misuse of data analysis called data dredging or p-hacking. This dramatically increases the risk of false positives or spurious correlations. So I would say when you're using public use data sets, you should really always go in to collecting data with a specific hypothesis in mind. Something like, I think that lung cancer rates may be affected by age, smoking rates, and radon, rather than let me compare a bunch of variables to lung cancer and see if anything pops up, and then just go with those results. So in conclusion, there's a lot of things you can do with public use data sets. I hope these examples were helpful. I think with that, we will switch over to the questions and kind of wrap up here.
Can I just jump in?
Sure.
Are you done?
Yep.
Yeah, thank you. This was really awesome and very salient to what we're all doing. I would like to ask you to clarify this one statement that seems very important to me. You were talking about that it's very useful for hypothesis generation, and I can see that now. You were very effective at showing that. But can you also explain your last statement about that you should really have a hypothesis ready? It seems to be contradictory there. You should, and I kind of understand what you're saying, but I'm sort of asking for your experience. You know, how do you weigh that?
Yeah, sure. I guess maybe what I would say is you want to go into it kind of with maybe intention, because like, for example, the lung cancer, maybe you're like, I want to know, say you didn't know much, I mean, lung cancer is pretty well known, but say there's another cancer like, I don't know, head and neck cancer. Maybe we don't know much about head and neck cancer. So you look at databases with people who have head and neck cancer and people who don't, and other variables, and maybe you're trying to see if there's any links between the two. Now, what might be a good sort of hypothesis generation idea is to maybe have looked into the research a little bit, try to pick out variables. Maybe you don't know what the variables might be going in, but you look at the variables available and you pick the ones that you think plausibly have some sort of connection. Like, well, maybe it's some sort of dietary preference, or maybe it's smoking, maybe it's age, maybe it's things that you could conceivably link to this, to head and neck cancer. More of the p hacking or data dredging way would be like, well, we just have 100 variables. Let's just run each of them without caring what they are, and then just only pick the significant ones. And then you might find significant values, but they might have nothing to actually do with head and neck cancer. They might just be by chance. Maybe there's variables about, who owns motorbikes, and it turns out people with head and neck cancer have higher motorbike ownership. Well, I don't think there's any actual link between the two, even though you found a significant link. And so there definitely is a sort of a fine balance between, trying to generate a hypothesis when you don't know about what might be going on, and sort of towing the line into just dredging up data to try to connect the dots just for significance. So that's why I would think maybe my rule of thumb would be, if you're intentionally picking variables and have justifiable reasons for them, you're probably doing a good job. If you're just doing something automatically, or even just having a machine sort of run through everything yourself, maybe not. Though I'm not sure. Obviously, there's a lot of things with machine learning and artificial intelligence that does things automatically, and I don't know enough about that to say what the right line between machine learning methods and data dredging is. And sometimes the uses are different, where an approach for one sort of question would be unethical, but then for another approach it might be just fine. So some of those questions don't always have a exact answer or a clear answer. So hopefully that helps a little bit.
Mark, can you speak to the availability of grant pipelines for?
Yeah, I just saw that
analysis?
chat. Let me read through it here. Yeah, I'm not really sure about that. Yeah, that's that is a interesting question, because yeah, while public use data sets may not cost you anything, analyzing, working through them, that, yeah, might take a certain amount of time, and grants don't generally say, oh yeah, we'll give you money just for your time. They usually want you to run some experiment, buy a machine to do something interesting, enroll patients. So I don't really know enough about if there are specific grants types that might be more amiable towards analysis. That might be
Well, and Mark, I was just wondering, so you're in a role where this is part of your job, and I would
Right,
think that
yeah.
most of us that are in this, because we, signed up to watch this, are in maybe in a different role, and we want to kind of slide over to data analysis.
Yeah.
So I guess that's what I was thinking, and like, I know you work probably for a state institution too. So any ideas that you might have about how to facilitate us moving in that direction was kind of what I was wondering about.
Yeah. So I guess, one thing would be possibly collaboration. For example, in my role as statistician and coordinator for the Biostatistics Core for DaCCoTA project, I can help researchers with data analysis, setting up data. So maybe, and so I have that's part of my job. And so if anyone has a question or need help, I can help them to whatever degree I can. And so that might be, either myself or maybe someone at your institution or something like that. Maybe if you're interested in doing more data analysis, but maybe you don't have enough time or can't commit enough time or resources to it right off the bat, maybe initial collaborations would help with someone that maybe has more time or that's more part of their job to kind of help improve that. I don't know if that really answered the question, but that's what came to my head.
Yeah, that's fine, Mark. I just thought maybe there was some, you told me about a couple websites today that I didn't know about how to, to mine data. I just wondered if there was a pipeline that I didn't know about, and that's okay. It's sad that there probably isn't, but in the context of, a lot of time and effort and money has been spent collecting this data. And in a lot of cases, there's a lot of questions that never get answered. And it seems almost silly that there isn't a grant pipeline or something to look at all of this investment that's already been made. But, if some of us can at least spend a little bit of time generating hypotheses and getting that published, then I think that's really useful for everyone. Yeah. Thank you.
Yeah. And I guess maybe just having a comment on that, one of the things I also hope for more literacy about public use data sets is maybe the question has already been answered that you have with a data set, especially maybe it's a question that you're not like burning to answer. You just, it's part of your research. You'd like to know the question, and maybe you have to do it yourself, but maybe you don't have to. And so that might help be a helpful step of like, oh, this has already been answered, so I can just take that answer and then work on the more difficult problem that I know I can solve in my lab or something like that. So
I did want to mention, excuse me, I did want to mention too that we are, on the website, we will eventually have a link. I think Mark, you mentioned that, but with a variety of data sets that you might be interested or could help your research. So you could be on the lookout for that as well.
here, I'll throw up the website link in the chat, just so people have that. All right, then, if there's not any more questions, thank everyone. Thank you all for joining. Hope this was helpful. Feel free to reach out to either of us if you have questions in the future.
Yes, thank you all. Thank you all again for joining. Enjoy the rest of your day.